Hello viewers, I hope all of you are fine. Today I want to discuss about the composite particles and the elementary particles. But before that, let's discuss some historical background about this. Basically, before 1950, electrons, protons are considered as a fundamental or basic particles. But after 1950s, it was experimentally confirmed that basically protons and neutrons are made up of further smaller particles which are known as quarks. So then after that, scientists decided that basically protons and neutrons are not fundamental or elementary particles, but that are basically composite particles, while electron is still considered as a elementary or basic fundamental particle because it is made up of nothing else. So after 1950s, hundreds of new particles are discovered which are known as a particle zoo, and most of them are discovered at experimental lab at CERN or Large Hadron Collider during the particles collisions, carrying a very high energy. Now let's discuss these two major categories of these particles. First one is called fundamental particles and other one is called composite particles. What are fundamental and what are composite particles? Fundamental particles are those particles which are made up of nothing else, or in other sense you can say that which cannot be further broken down into more smaller particles, or you can also say that which having no substructure. So fundamental particles having no substructure are made up of nothing further other material, while the composite particles are the combination of other particles, or it is made up of something else. So now let's discuss first the fundamental particles. Fundamental particles basically consist of leptons, quarks and bosons. Basically all leptons and quarks are fermions because leptons and quarks carry half integral spin, while bosons are basically carry integral spin. So those particles which possesses integral spin are basically called bosons, and those particles which carry half integral spin are basically called leptons. So leptons and quarks are fermions, while bosons, which are basically proton, WZ boson, gluons, Higgs bosons and the gravitons, all of these are basically bosons because these are basically integral spin particles. Basically leptons are fundamental particles and they are 6 in numbers, and similarly there are 6 anti-leptons because in universe every particle has an antiparticle. What are 6 leptons? 6 leptons are basically electrons, muon and tau. Similarly they are corresponding electron neutrino, muon neutrino and tau neutrino, and their corresponding 6 antiparticles are basically positron, or you can say that anti-electron, anti-tau, anti-muon, anti-electron neutrino, anti-tau neutrino and anti-muon neutrino. Now similarly quarks are the basic building blocks of all matter. And what are the number of quarks? Basically quarks are 6 in numbers. And what are that 6 in numbers? Basically that 6 quarks are up, down, charm, strong, top, bottom. The up charm and top quark possesses +2/3 charge, while the down strange and bottom quark possesses -1/3 charge. So similarly besides 6 quarks there are also 6 antiquarks, and that 6 antiquarks are represented by the bar sign above these quarks. For example, U bar, C bar, T bar, D bar, S bar and B bar. So by taking the bar of these all quark, or by introducing the bar sign above these, we can represent the antiquark, because in this universe every particle has an antiparticles which we can represent like this. Now what are basically the other category of fundamental or basic elementary particles which are made up of nothing else are basically the bosons, which are possesses integral spin, and in that category the photons are lying. Photons are what? Photons are basically the mediated particles which carry the electromagnetic interaction or electromagnetic force. Similarly the W and Z bosons carrying the weak force. What are gluons? Gluons are basically the force carrier of strong force, inside the nucleus. And you people also know very well that strong force basically is between the hadrons, or basically in between the quarks, or you can say that inside the nucleus basically the strong force exists, which is because of what? Which is because of the gluons. And the Higgs boson basically carry the Higgs field, and the graviton basically, these are called the theoretical gravitons because still it is not confirmed, but we can assume that basically the force of gravity is carried by the gravitons. So these are basically the different categories of the fundamental particles. And what are the composite particles? Composite particles are basically the hadrons, and hadrons are basically made up of either 3 quarks or either 2 quarks. Now hadrons has 2 categories, one is called baryons and other one is called mesons. What are baryons? Baryons are that class of particles which consist of 3 quarks, or which are made up of 3 quarks, while mesons are made up of 2 quarks. Now example of baryons are proton, neutrons, lambda baryon, sigma baryon, xi baryon, and the omega baryon. Now for example, if we take proton, then proton is made up of 3 quarks. And what are that 3 quarks? Basically 2 up quark and 1 down quark. And you people know very well that up quark possesses plus 2 by 3. So it means that 2 up quark plus 2 by 3 plus 2 by 3, and 1 down quark minus 1 by 3. So it gives us charge 1. It means that proton possesses charge 1, while the neutron possesses no charge because it is made up of 2 down quark and 1 up quark. And you people know that down quark possesses minus 1 by 3. So minus 1 by 3 minus 1 by 3 and plus 2 by 3 becomes, their addition becomes 0. So that's why neutron is a neutral particle, while proton carrying a charge of plus 1 according to this categorization. Similarly, you can also conclude the sigma charge, which is a sigma neutral, which is made up of UDS, up, down, and strange quark. Similarly, lambda is made up of UDS, which is the neutral lambda baryon. Similarly, the sigma. Similarly, you can also conclude, or you can also calculate the charge of the xi baryon, and similarly all of the rest. Now, what are basically mesons? Mesons are basically that class of particles which are made up of 2 quarks, and that 2 quarks are basically quark anti-quark combination. For example, the pi plus meson, pi plus pion made up of up quark and 1 anti-down quark. Similarly, the neutral pion and the negative pion, you can also calculate their charge as well. Similarly, the kaon category also made up of quark anti-quark combination, whether they are neutral kaon or whether they are positive or whether they are negative. Or you can also calculate the eta charge. So all of these are basically the categories of different particles which are maybe fundamental, or which may be not fundamental, or you can say that which may be composite particles. So I think you people learn a very basic idea about all of these different types of particles, which are known as the particle zoo, and major revolutions comes after 1950 in this field, which is known as the particle physics. So if you like this video, then please kindly subscribe my channel. Thanks for your time.